threading on the lathe. We're going to be running the Haas TL1, but this will work with just about any CNC lathe or turning center that you might have. So in this one, this is turning number 5. We're going to start with a piece of stock. It is going to be about 1.25 inches in diameter. It's going to stick out of the chuck about 2.5 inches long. We're going to cover some of the things that we've done before. That's going to be it's going to include facing and turning on the OD, using a roughing cycle, G70, G71 for roughing and finishing the OD of this thing. We've got some circular interpolation, some corner rounding happening here for both, just here in this corner, this inside corner, and then this outside corner, so G2 and G3. We'll part the part off, and then we will also take care of the threading. And the threading is our new part that we're going to be working on today. Our thread is going to be a 3/4 16 threads per inch. So the TPI for this is 16 threads per inch. So in order to figure out feed rate for that, it's going to be 1 divided by 16. We'll walk through that as we go. So we're not threading all the way down the length of this part. We're just going to do part way down and about 3/4 of an inch long that we get full thread on this thing. And so this is just a kind of a typical bolt. Maybe it gets a secondary operation where it gets a hex milled on the backside or something like that. Could get a slot, could get a socket head on for an Allen wrench or something like that. But let's get started with this part. So when we start this part out, I've got a couple of programs already started that I've been playing around with. First thing I'm going to do is go ahead and turn my caps lock on. I'm going to start with the % sign. My font's a little bit smaller. It feels a little bit smaller today. So I'm going to start with the % sign, and then I'm going to start, as I always do, O, and then 0, 0, 0. I'll use 5 today since this is turning 5. And so I'll go ahead and put just some information about it. I'm just going to say turning 5. Put that in parentheses, and then I'll also write down in here. I'll put my name just so I know who did this. Maybe I would put my date in here when I created this program, so that when I go back to edit it, I would know when it is. May also put some type of revision in there if I revised it a couple of times. So this will be enough information just to get me started. So what we're going to use today when we start this part, we're going to start using tool 2, and we're going to use tool 2 as a 80-degree turning tool. We're just going to say it's got about a 15 thousandths tool nose radius on it. For corner rounding calculations, we're not going to include any of those things in it. That'll be something that we can walk through later on. But for right now, when we do corner rounding, we'll just do it as though it has no radius to it at all. So let's just consider it to be a finisher. So we'll go T202, and we're just going to call this our facing / turning, OD turning tool. Okay. I get us started there with the tool change, and probably even before I went and did that, I want to come back up here right above it, maybe enter in a line there and do a home G28, home all max. This is before I get started. So I might do a typical startup line with G0 and then G20, G40, G80, G90. That sets me up into rapid motion, sets me into inch input, cancels out any cutter compensation, cancels out any can cycles, and it puts me in absolute movement. So most of our machines that we're going to run, or most of the machines that are kind of out there right now, are going to already have those as modal, so they would be active until they were changed. Moves like this or lines like this are pretty cheap to put in. I mean, everything takes time to read as far as the program goes, but it's not going to take an exorbitant amount of time to do this. So it's a good and safe thing to put this into your program so that you don't have errors, or just really small errors that might cause you big amounts of wasted time. There's, the big time waster that I think people have a lot is that they would end somewhere or move somewhere in the program using a G91, and then they don't switch it back because it is modal. And what they find is the part keeps moving down, and then they try to zero it out, and it's not going back home to the right spot. So if you put these in your tool changes all the time, then this always kind of resets those things, gets those things back to normal. All right, so at this point I haven't really moved anywhere other than the home position. I might go ahead and put in a G50, whatever I want to max my spindle speed to. 1200 has kind of been my go-to number lately. And then I would do a G96, and so G96 is going to be constant spindle speed or constant cutter speed. So my spindle is going to speed up and down as I go. So as I face the part off towards the center, the spindle's going to speed up. As I move out, it's going to slow down. So as I go there, so maybe I'm working on some stuff that maybe has an 800 surface footage for the material. So I go S800, and then I can turn my spindle on from this point. Now, if I didn't want that, if I didn't want my spindle to speed up and down, I might go do something like this, G97. And then, say I just want to run a spindle speed at like 750 RPM, 750, and then turn my spindle on from right there. Do the same thing. So I don't want to use both of those at the same time, but I could use either or. But just if you remember this, that using your G97, it's going to stay at that speed all the time. There are definitely times that we do not want our spindle to speed up really fast, especially if it's a long part, a skinny part. Something that's going to add some vibration into our part. A lot of times you see that if you're using a long bar feeder, you do not want to start to wrap that thing up to super high RPMs with a 20-foot bar on the end. So you want to be kind of mindful of some of those things. So here we don't really have that situation. We've got it chucked up. We're going to be able to do G96 800. We do want to max our spindle to just to 1200 RPM, which would be fine. So at this point, again, I've now just turned the spindle on. I've homed it out. I've turned the spindle on. I've got some codes in, but I haven't really moved anywhere yet. So I want to go ahead and enter in my work offset. That's going to be G54. For this, I don't really have to put anything other than that. If you're using multiple offsets, or if you're using some work shifts, some other programs or some other parts in conjunction with this part, maybe you're making a family of parts that you might do some shifting or some multiple offsets in there, but here we're not. So we'll just use a G54 to set our work offset. So now we can go ahead and do a G0, so it's a rapid command. And we'll go to X of 1.25. Let's go to 1.27, just to give ourselves a little bit of clearance area in case this thing's wobbling or it's just out of round a little bit. So X of 1.27, so just a little bit over 1.25 inches. Z of 0.1, so 100 thousandths in front of our part. We'll go ahead and wrap it over to Z0, and then we will G1 feed move into or down to X minus 30 thousandths. Okay, so on that line I have to have feed rate, so feed 12. And so that's a feeding move going down the face of this part. And again, so my spindle's speeding up as I go down into the middle of it. Next, I'll switch back into a rapid motion. I'll go back to my start point of 1.27, Z at 0.1. I'm ready to move into my roughing cycle. So to create the roughing cycle for this part, it's pretty straightforward. And it's the same thing as what we've seen in the videos before. So we're going to just define the outside, the finished profile of this part, as though we were going to take this and make one big cut across it with our turning tool. Okay. So we do have to know some stuff about this part. One of your best resources to find out some of that information is to go to something like the Machinery Handbook. It's really going to help you find out how far you need to go, where you need to go, some of the other things that you might need to do. And for me, on this part, I would look at my minor diameter and make my chamfer just a little bit smaller than what my minor diameter of my part's going to be. So as I go through here, because there's no specific size of the chamfer, so as long as I go down below the minor diameter, I should be okay. So I've already taken and made some notes for myself about minor diameter and the pitch and stuff for this part. That way we didn't have to go through some of those things. So minor diameter for this part, if I go down to 650, I will more than clear that area. Typically on your print, it's going to give you some information about what size that chamfer should be. Here it doesn't give us that information, so we just want to make sure that we're going down below it. So I'm going to go ahead and go into a G71. That's my roughing cycle. So G71 is going to be a P1, it's going to be a Q2, it's going to be U of 10, a W of 5, depth of cut of 75 thousandths, and a feed rate of, let's say, 15. And so just to go back over a couple of those things, G71 initiates my roughing cycle. P and Q define where my profile starts, where my profile ends. U and W are my incremental offsets, so radial offsets, how much I want to leave on stock for X and Z. And then depth of cut is going to be 75 thousandths. My feed rate will be 15 thousandths per revolution. So now N1 is the same as P1. I'm defining the beginning of my profile. And so it is almost always going to start with a rapid move, G0, to my lowest. So on external, it's to my lowest diameter. So rapid move to my smallest diameter. And I think we said we would go down to 650. So rapid move down to 650. My next move, and here I don't want my numbers to continue on, so I'm just going to back those out as I go. So I only want to use N1 and N2 on there. Just that's personal preference. You can absolutely number every line. It's not going to make any difference at all. You just need to be able to change your P and Q to match your starting point and your ending point for your profile. So I've got my rapid move to my smallest diameter, and next move is going to be a G1. It's going to be a feed move, Z to 0. And on that one, since it's a feed move, I can go ahead and put a finish feed rate on that line or not. I don't have to. I've already defined a feed rate there. So I'm going to go ahead and feed up to 0. From this point on, I would go over to, let's just say on this part, and I probably wouldn't do this if I was, depending on if I had a little more information on the threads, maybe I would, or maybe knew the application of what I was doing. I might turn these threads back a little bit lower, because typically for a 3/4 16 bolt, the OD of the threads is going to be something more like 746, and then I would skip up to 750 as I went back across here. And so we can go ahead and do that if we want to. So what we'll do is we'll go back to X point 746, Z minus, let's go 50 thousandths, just to keep that pretty close. We really need to go down here in order to keep that perfect. We'll go down to 646, and then if we go to 746 and then back 50 thousandths, that'll make a 45 thousandths chamfer. So from this point, I've created just the front chamfer of the part. So I want to go ahead and feed back, continuing in G1, Z minus 0.75, and I'm stopping there because I need to jump back up to the 750 diameter. And even though 2-place decimal, I've got tons of tolerance on there, I still want to try and get as close to nominal as I can. So I'm going to feed back to 750, and then I'm going to jump up to X of 750. So I'm just making a 4,000 step up there. And then from this point on, I'm going to start working backwards as I go. And so what I want to do is I want to go ahead and come around this corner. And as I do that, I'm going to go ahead and do, let's see, I went up to 750. So now I'm going to get into this corner radius here. 1.75 is my length from 0 front of the part to back here. So I know I've got my 100 thousandths radius right here. So what I'm going to do is I'm going to go ahead and cut that short. So I'm going to go Z minus 1.65. I guess actually I have to type Z minus 1.65. Takes care of my length back there. Next move is I'm going to go ahead and go into a corner rounding motion, so G2. And where I want to land is I'm at 750. I'm going to do this radius here. So add 100 really to each side of it. So adding 200 to 750 puts me at X of 0.950. Puts me at Z minus 1.75. And so for this, I can just add in an I of 0.1. And if I want to, I can go ahead and put in K0. Just and you can also do that as an R if you wanted to. I know the simulator that I'm going to be running in, and I know that it works better with I's and K's. So as we simulate it, just to make sure we don't have any problems, either way will work. But I know simulation-wise that this is going to work a little bit better. So now I need to feed up to, I can't feed up to this corner, but I come up here and I've got a 50 thousandths radius. And so I want to feed up, but I don't want to go all the way up to 1.2. I actually just want to feed up to 1.1. So since G2 is just like G1 and G0, it's modal, I have to jump out of G2. So I go back to G1. I feed up to X of 1.1. And so now I'm going to go into, I'm going to turn the corner the other direction. So I'm going to go G3. I'm going to go to X of 1.2. I'm going to go to Z minus, I've got to go 100 thousandths beyond that part. So I'm going to go to Z minus 1.85. 850. Either way it would work. On this one, I'm going to have an I of 0 and a K of minus 100 thousandths. So that's going to take care of that radius of where it's going to stop at. So as I jump back through here, or let's see, that K, that's not right. Let me jump back here. So this is going to be from 750. This is actually going to go to 800. And this K should be minus 50. In my mind, I was still thinking about this 100 thousandths radius. So I'm only going back now. So 1.1 is correct. We go up to 1.2. We're going to go back 50 thousandths. I is still going to be 0. K is going to be minus 50 thousandths. Okay. So it takes care of that corner radius there. I'm going to go ahead and go back a little bit further beyond the part, just to make sure that whenever I do secondary operation or part it off, that I would have enough clearance from that. So my part's 2.5 long. So I go back into G1, and then I would go Z minus, let's just say 2.6, just to get back beyond that part. Now at that point, I can move back over here and I can do N2, and that takes care of my profile for that part. Okay, so what I would probably do at this point is go ahead and bring in, I could do a couple of different moves if I want to stop after I rough this. So it's gonna rough this part out, and it's gonna do a pre-finished pass across it just to knock out the steps that are in it. So I can be taking it to size because I already said up here that I want to leave stock on the diameter and the length. So if I wanted to, I could go ahead and do maybe a G0 X 1.27 Z 1 inch. That would put my part, that would move my tool out in front of my part by an inch, and then I could do an M00, and I could put check diameter. I could do that, and then just restart the program back up. If I was going to restart the program back up, I would go ahead and do this. I'd copy this back out, and I'd set it back down here. in doing that, you want to remember this, that it's only roughed it out. So like I might even come in and do 2 G70s, one leaving 5 thousandths on it, and then the next one bringing it to size if I wanted to do that. So this is just giving you a couple different options or a couple different ideas of being able to do some stuff. So here I've roughed it out, and then I did an M00. That was an absolute stop. I checked the diameter, so first spell that correctly. Check the diameters and or check the diameter. Let's do diameters. Recall this tool back up and then go back in and just do my G70 from this point. P1, Q2, and put my feed rate on there if I need to. I do need to because I haven't put it anywhere else in the program. Feed 8. And after that, I can go ahead and go back. Then I probably would move back out of the way. So G0, X 1.27, Z maybe 5 inches just to get myself cleared up out of the way. I can do an M01 if I wanted to, optional stop. Just in case I wanted to check that as I went. And then after my parts are running, I turn optional stop off, and then I wouldn't have to worry about that anymore. So now I get into my threading tool, and for this one, my threading tool is going to be tool 3. And so I want to just kind of continue to utilize that copy and paste that I have, and I think that I still have it ready to use, yeah. So I'm going to change this to 303, and I'm going to make it my OD threading tool. OD threading tool. Let's see. Let's think about RPM wise just a little bit. Just a little bit of room. We can play around with this RPM a little bit. That might be a little fast for doing some of our threading. Might be moving across it pretty fast, but it's aluminum par. We're just going to assume that all of our inserts are good. Again, if you remember, I don't have coolant on in this program at any point. I would go ahead and run this part through, make sure that I'm happy with it, just turning the coolant off and on as I went, and then I would turn my coolant back on M8 somewhere in the program, and then just M9 at the end if I needed to. A lot of times an M9 would be unnecessary because just when you hit an M30, it's going to turn it off anyways. All right, so we'll continue on with this same RPM or surface footage. So we want to come in, and I really want to do 2 different kinds of threading on this part. And I think you'll find this is going to work most of the time, but you might find yourself wanting to do a couple of different things. That's why I want to show you the second one. So I'm going to go ahead and wrap it up to G0, and I'm going to go to X of 0.76. Now my diameter is much smaller, and I'm going to go to Z of 0.1. From this point, I want to go into a G76, and for the G76, it's going to, actually let's make our math just a little bit faster and easier. So I'll go ahead and go down to 750, and so let's just assume that on this part, we've got a minor diameter of about 705. Actually, we can make ourselves really easy if we wanted to, so we'll go to 755. So we'll go G76. Our X is going to be how far down we want to go. X of 705. Well, 705. So that is our minor diameter that we're going to finish from. This G76 is going to draw from this G0 and start doing kind of some of the math from there. So from where we start to where we end, this is how we're going to start dividing up our passes. So we want to finish at, say, 705. I think that's what I had written down earlier. Pitch is 705. Let's go down to 675. So we'll go to 675. Okay, still keep those numbers kind of even. So we can go back over here and go back to 750. The only reason I'm changing this diameter up here, I don't want to go below the diameter, but it's going to make my math just a little bit faster in my head to kind of work out some of these things. All right, so I'm only going to thread back 750, so Z minus 0.750. And now for my thread, I can leave stock just like I did in my roughing cycle where I use my U and my W. I'm not going to do that. I'm not going to take any spring passes in there. I do need a K value in there, so we'll go ahead and put a K. And so I'm going to go ahead and pull that up. So I go from 750 and then I subtract 675 from it, and then I divide that by 2, and that just gives me my radial value of my thread. And so what we have here is 25 thousandths, so K is 25 thousandths, and then I need, I believe, an I. Nope. I need a D, and I can have an I if it's going to be tapered. But so my D is going to be my thread of my depth of my first pass. My first passes can always be much heavier. From there on out, it's going to start calculating smaller values as it goes down, kind of depending on which one I use or which threading cycle that I use or how I've got my parameters set up. Could also do a chamfer at the beginning of the end, an automatic chamfer at the beginning and the end. I can plunge my thread in, or I can even feed on the front edge of it, kind of going in at that angle like you might be doing on a manual lathe. Last thing I need to do is come up with the feed rate. So feed rate is 1 divided by the threads per inch. So for us, we have 16 threads. So I will just come up and I would take 1 divided by 16, and I get 62.5 thousandths. So my feed rate is 0.0065. Okay. So from there on out, that would conclude my threading. So my threading would be done after that. So what I would do now is I might do a rapid move G0 and go to X of 1.27Z.1. Then maybe I would do a rapid move back G0. Actually, I need 0 there. Say maybe Z5, and then do an M30. From there on out, it kind of depends on what I'm doing with my part. Am I parting it off? Does it transfer to another spindle and then get cut off? What's going on with it after that? We've covered G75 and some other cutoff cycles, so I won't do those things. I really just want to work on threading today. So so here's one. We'll go ahead and finish this guy out, and then I want to come back and I want to show you one more type of threading that we can do. So I want to make sure I make a note of that we cover the G92 before we end here today. So we'll go ahead and save this thing. Go to the Haas lathe plotter. Turn this thing on, reset. Going to receive RS-232 from the desktop, and there's 5. Open it up. Let's see, and go ahead and start. Okay, so I've got a problem in my program where my program starts. So I have a G71, G72 problem, and so using these simulators, it's not always perfect. Sometimes it'll give you an alarm when you don't even actually have an alarm. So let's go back into the program and see if we've got an actual problem in our program. So We'll minimize this. And our program 5 is here. Open that thing up just a little bit bigger. And our program problem is in our roughing side. Okay, so I had to stop for a minute, figure out where my program problem was, and then come back to it. And so what I had was an error in right around here before I went into it, must be right around this line. I forgot to put an X. So it was missing an X in this rapid move. I've got it in there. So as I was working through it, I just kept doing some revisions. So I made some changes, did revision B, made some changes, revision C. So I figured out where my problem was, got it back up and going, and so now I'm back into my simulator. One of the problems that I kind of have with the simulators is that they're different than the machine, where the machine's going to let me kind of walk through some of the steps, and it's really going to highlight kind of not so much line by line, but the machine's reading about 3 lines ahead. So I can pretty much tell where my program problem is within 3 lines. So simulator is really good, because if I was standing in front of a machine, I would have really lost some time there. But this way, I haven't lost any time, cycle time. I've just lost a little bit of program time, which is just more frustrating than anything. All right, so we're going to go in, we're going to find this program. On our desktop, it is now 5C. Open it up, and you can see I've already got the simulation run for it, just because it knows that it's right. So let's go ahead and run through part. Get a little bit better simulation of what this thing might look like on here. Turn this thing on, reset, set some stock. Let's see, we need something a bit bigger than that, 2-inch diameter stock. Reset. Go ahead and pull up our program. 5C. Open that thing up. Hit cycle start. So we're facing it off. Returning the OD. Hit cycle start again. Takes our radiuses, takes our part back. Now we'll go to the threading tool. So what I want to do now is I want to go into another one. I want to leave most of this in here and just go in and change some of the threading options on it. Immersive isn't going to let you simulate this one because they don't support the G92. And so G92 is what we're going to use. And so what we're going to do is we're going to take out this section right here. And so instead of using a G76, we're going to use a G92, and it's a modal threading cycle. And so what that's going to allow you to do is you can come in and go X. So let's say we want to take our first pass at 730, and we want to feed back Z minus 0.75, and we want to feed at 0.0625 for our thread, for our feed rate, for our pass. So that's just going to do one single pass. So it came up to X is 750, Z of 0.1. Now it goes into the G92 threading cycle. It goes down to 730 and threads back 750 at a feed rate or a pitch of 1/16 of an inch. So that makes our thread right. Now, that's just one single pass. But all I have to do is, since this is modal, I can now go in and go X point 720, X point 700, X point 680, X point 675, If I want to do a spring pass in there, I could do X675 again. So here's the advantage in this is it gives you a little bit of freedom to do a couple different things. If you want to really fine tune your depth of pass, maybe your first 2 or 3 passes are going to be real heavy, your last 2 passes are going to be really light. Here's a great way to do that. Also, if you need to do like an oil ring groove or some other type of spiraling shape that you need everything to synchronize, but it doesn't necessarily need to be a thread, this is also a pretty good option to use. A lot of times it'll allow you to go with your pitch just a little bit further out. So an oil ring groove, maybe over 4 or 5 inches, might just do 1 full circle or 2 circles around it. It'll allow you to move that pitch out further and have some little more freedom in doing that. So that's just a secondary option for threading. You can use on a lot of different controls. You can use the G76 or the G92. Just kind of 2 different ways of doing the same thing. All right, so give that a shot and see how it goes.